Alright, we're working on estimating the standard deviation of group data. The reason we have to estimate it is because once the data has been classified into, or grouped into classes, we no longer have the original data, and therefore any approximation we make is going to be estimated from the midpoint and not the original data array. So much like we did with estimating the mean of group data, we're going to go through a nice little procedure to arrive at our answer. Okay, first thing is the author says you can set up a table using these as your headings. The class, I like to just go class 1, 2, 3, and 4, or A, B, C, and D, whatever you want to do here. So now A, B, C, D. Let me scroll down a little bit. And that's our classes. The frequency of class A is there was 6 elements of the data set that were part of class A, 8 to class B, 8 to class C, and 2 to class D. Next we have to get the midpoints. The midpoints are negative 1.2, negative 0.4, positive 0.4, and 1.2. And I'll write those down over here. Negative 1.2, negative 0.4, 0.4, and 1.2. Next column is the frequency times the midpoints. So for each class I'm going to do the frequency times the midpoint. So negative 7.2, negative 3.2, positive 3.2, and 2.4. Last column is going to be the frequency times the square of the midpoint. So the square of this is 1.44, the square of this is 1.6, 1.6, and then 1.44. If I do 6 times 1.44, I get, let me think, 8.64. 8 times 1.6 is 1.28, and so that's 1.28 also. And then 1.44 times 2 is 2.88. Okay, having done that, I can now do the last step. Find the sums of columns B, D, and E. B, the sum of column B will be the sample size, which is 24 in this case. I need more room. Let me scroll down. The sum of column D, this is the F times XMs, so this will be the sum of the F times XMs, and you can see these 3.2 cancels out. They have opposite signs. Now 7.2 negative plus 2.4 is negative 4.8, and then this is 2.56. 2.56 with this is 10.20 plus that is 14.08, and now I have, that's the sum of the midpoints, the frequencies times the midpoint squared. Now step 5, I use this formula. The formula says the variance, or our estimate of the variance, will be equal to the sample size times the sum of the frequencies times the midpoint squared minus the sum of the frequencies times the midpoints squared, all over the sample size times the sample size minus 1. Alright, so I'm going to fill in all the blanks, and then I'm going to use a calculator. So we have 24 times 14.08 minus negative 4.8 squared. And because it's negative that's getting squared, this negative will go away. Alright, so you can actually leave that out of the calculation if you want. Divided by 24 times 23. This little dot here is a times. Alright, so I'm going to do this on the calculator, close that parenthesis. Here we go. Parenthesis. Oh, my calculator's dead. Alright, so maybe I can use Alex's calculator. Are we still alive? Yeah. So clear that. Parenthesis 24 times 14.08 minus what was it, negative 4.8? So 4.8 squared. Let's close that parenthesis, divided by 24 times 23. And if you want to put parentheses here, you can. Alex has already grouped them in such a way that the parentheses were implied, so it's not really necessary. But I hit equals. That's 0.5704 is my variance, so if we square root that, we get 0.7553. So 0.5704 is that, s squared, so s is 0.7, what was it, 0.7, I don't know, 0.7553. Alright, so that's that one. I'd like to do another one, but I'm already well into time here, so I'm going to do it on the next video. There we go. Stop.